Okay, welcome back to the 3.1 notes, and this is introducing the derivative. For the problems that I've assigned, I want you to do these three things here. Calculate the derivative f prime for the given function f of x, determine an equation of the tangent line at P, and then plot the graph of f and the tangent line at P. So let's go ahead and let's just go ahead and get started. Remember, to generate the slope of the tangent line, okay, that means that that's the same thing as my derivative, f prime of x, and that's equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so I need to use this, okay? The first thing that I want to do is I have my function f of x. Okay, the next thing I want to do is find out what f of x plus h is. Okay, so to figure that out, guys, I'm simply substituting x plus h in for the x into my function. Okay, so everywhere where I had an x in my function f of x, I'm now going to write x plus h. All right, so we've got 3 times the quantity x plus h, quantity squared, minus 4 times x plus h. Okay, so if I wanted to simplify this, okay, f of x plus h is equal to 3 times the quantity. If I take x plus h and I square that, that means you're just doing x plus h times x plus h. All right, and I'm going to multiply that out. You're going to end up getting x squared plus 2xh plus, what is that, h squared? Okay, and then minus 4 times x plus h. And let me go ahead and distribute my 3 and my negative 4. So I get f of x plus h, oh dear. I get f of x plus h is equal to 3x squared plus 6xh plus 3h squared minus 4x minus 4h. Okay, now here's the thing. All right, this is my f of x plus h. Okay, this is my function evaluated at x plus h. This is my function f of x. Now, putting it into this limit notation is a little tricky. Okay, so bear with me. All right, so I'm going to do this. All right, I'm going to put this in red here, and I'm going to put this in green. Okay, so my function f of x is in green. My function f of x plus h is in red. Okay, so as I substitute this in, okay, here's what I've got. I've got and I got to write this out. So I'm going to use blue. Okay, f prime of x, my derivative. Okay, calculating the derivative. That's what I'm trying to do here. F prime of x is equal to the limit as h approaches 0 of f of x plus h. Okay, now instead of writing f of x plus h, I'm going to write what f of x plus h is equal to. I'm going to write, and let me change to red, I'm going to write 3x squared plus 6xh plus 3h squared minus 4x minus 4h. Okay, and then I'm going to subtract my f of x. Now, guys, I'm subtracting a function here. This is an entire quantity, and this is where you're going to get screwed up, okay? When I subtract this, I want to always put this in parentheses, and I'm going to write out my function, which is 3x squared minus 4x, okay? And that's going to go in parentheses, and then I'm going to divide all of this by h, okay? So now, I've evaluated f of x plus h, plugged that in. I've plugged in f of x, making sure that I subtract the quantity, and this is all over h. Now, guys, remember with limits, what we're doing is we want to do direct substitution. Now, here's the problem. Here's where you're going to get confused. X is my variable. H, remember, is a distance. Okay, it comes from this. H is this. So I want to plug in 0 for h. But I got a problem here. I've got an h in my denominator. If I plug in 0, it's indeterminate. So I need to do a little bit of work on this. Okay, I need to do a little algebra. Well, let's go ahead. Let me distribute my negative, and let's see what happens up top. All right. So I get this. I get the limit as h approaches 0, and I'm going to write this in blue. 3x squared plus 6xh plus 3h squared minus 4x minus 4h, and then I've got minus 3x squared, okay, and then I've got minus negative 4x, so I've got plus 4x, and then this is all over h, okay? Oh, wait, guys. Wait a minute. Maybe you see this. I hope you do. Okay. I've got some things that cancel out. Okay. I've got 3x squared minus 3x squared. That adds to 0. Those can get crossed out. Okay. I've got negative 4x and positive 4x. That cancels out. That adds to 0. Okay. So now take a look here. All right. Now I can say this. The limit as h approaches 0 of 6xh, right, plus 3h squared minus 4h all over h. Now take a look, folks. Okay, I have an h in every term in my numerator. Okay, so I can factor out an h here. And I get the limit as h approaches 0 of h times 6x plus 3h minus 4, okay? And this is all over h, all right? And so the h's divide out at this point, and look what I have. I have the limit, you know, I'm going to write it below. Sorry, there's not that terribly a lot of room on your paper, so just kind of bear with me. Sorry about that. Sometimes these require a lot of work. Okay, the limit as h approaches 0 of 6x plus 3h minus 4. Now, because I'm not dividing by an h, I can go ahead and plug in 0 here. And so I don't write my limit anymore. And I have 6x plus 3 times 0 minus 4. And if I evaluate this, I get this. I get 6x minus 4. Folks, this is my derivative. Okay, it's a lot of work to get it, but we'll get there, okay? And so here's what I want you to write. This is equal to f prime of x. Okay, so f prime of x is equal to 6x minus 4. Okay, that's the first thing that I want to do is calculate my derivative, all right? Now, the next thing I want to do, all right, so let me write that up here, okay? So let me write up here that f prime of x is equal to 6x minus 4. Now, remember what the derivative does, folks. The derivative is a function that generates the slope of the tangent line at any x value. Okay? Now, what we want to do is we want to look at point P. Now, P is the point 1, negative 1. All right? So what I want to do is I've got an x value. So here's what I've got. I've got my derivative. I have an x value of 1. I have a y value of negative 1. And if I want to determine an equation of the tangent line, an equation of a line, I need a slope and a point. Okay, so I need to find my slope. Okay, but I want to find my slope of the tangent line when x is equal to 1. So what I want to do to find the slope of the tangent line, okay, at x equals 1, then I plug in 1 into my derivative. I find f of 1. And I take 6 times 1 minus, whoop, let me just erase. I'll do 6 times 1 and then minus 4. Okay, minus 4. So 6 minus 4 ends up just giving me 2. So my slope of my tangent line is equal to 2. Okay, so let me do part B. Okay, so now we've got this. Now I've got y minus y sub 1 is equal to m times x minus x sub 1, okay? And what we can do is we can just do this. We can just do y minus y, and I'm going to do this y1 and x sub 1, is I'm going to plug in -1. So y minus -1 is equal to my slope, which is 2 times x minus, what do we got, 1? Okay, so one of the ways you'd probably want to write this is y plus 1 is equal to 2 times x minus 1. Okay, this is fine, but let's go ahead and put this into slope-intercept form, and so we get y plus 1 is equal to, let me distribute my 2x minus 2, and then subtract 1 from both sides. So let's take a look here, guys. I get this. I get y is equal to 2x minus 3. Okay, this is my derivative. This is the equation, okay, of the tangent line. All right, now what I want to do, let's just go ahead to our calculator. And I want to plug in both of those equations. Let's see what happens here. So I'm going to go to y equals, okay, and I'm going to type in, what was that? 3x squared minus 4x, 3x squared minus 4x, okay? And this is my original function, okay? And then I'm going to type in the equation of my tangent line, which is 2x minus 3, okay? And I'm going to hit zoom 6 on that. Zoom 6. And let's see what we get here. And I'm looking for what's happening at 1, -1. And boom! Check that out. Oh, yeah. That's what I'm talking about. Let's zoom in on that. Let's see what happens on that. Let's zoom box that. And I'm going to move up my arrow. God, that is just like, it's like, folks, it's like art. Okay, this is so freaking awesome. I don't understand. I mean, look at this. Look what we just did. I mean, we just calculated the slope of a tangent line here. And guess what? Guess where that intersects? It intersects at the point 1, -1. All right, I'm going to zoom in on that. Oh, yeah, that's what I'm talking about. That is legit. Oh, crap. Let me just zoom in on that. Zoom in. Zoom 2. And just hit enter. All right, there's my parabola. Okay, here comes the tangent line, and it's going to hit it. Boom! What is that? Is that the point 1, -1? I don't know. Is that good? Did we get that right? Is that fun? Pretty awesome to me. Okay, so, okay, maybe you guys are realizing that this is a lot of work, and it is a lot of work, okay? But I wanted to go through that pretty slowly with you, and I'm going to do the next 3 examples. It might take me a little while to do them. I wanted to go through this pretty slow so that you saw how I plug things in. My process of doing this in the next videos isn't going to change. It's just that my functions are going to change. Okay, if you have a square function or like a quadratic function, those are pretty easy to do. Okay, there's not a ton of work. When we start getting into like polynomials of degree 3 or degree 4, and we start doing you know, square root functions and rational functions, things can get a little strange. Okay, but let's go ahead. This is reasonable. Let me go ahead and stop this video, and I will let you guys work on that. So expect another one. Thank you.